So we will conclude the course this week. We will do essentially a revision of 2 or 3 things in the course, but using our implementation. So far, last time we did this model called the random effects model. So today we will review the random effects model with an example in R, and also do a comparison of ANOVA as well. That's the plan. So there's a sort of a historical note that I would like to sort of state in some sense. So this effect of random effects was done by a person called Eisenhardt. This was in 1947. They were the first to explicitly define this fixed effect versus random effects. So they were the first to sort of interpret this fixed versus random effects model in ANOVA. So today, typically somehow many people call Eisenhardt's second model as the random effects model. So today we'll work with one example, and then I will fluctuate between the iPad and the notes and the R implementation. So what I'm going to do is I'm going to take a data set that considers sodium content in beer. This is the data from North America. It's a US one. It's a USC data set. And what it did was it analyzed 6 brands. So it analyzed 6 brands. 6 brands. And per brand, what happened was that 8 ounces of in each brand, 8 so let's call it 8 8 12-ounce bottles were sampled. 12-ounce bottles were sampled. And the sodium content in milligrams were measured. Okay, and sodium content in milligram were. That's the experiment that people did. So let me write down the key questions of interest. So this is the experiment. This is what was done. This is the, for lack of a better word, I just call it an experiment. And let's go and mark down the key questions that one tries to understand. So let me pink. Let's say the key questions. Some of the questions one wants to understand from this experiment. So what would you like to understand? You would like to see if the expected value of sodium content for a given brand, right? So let's write down the first question is what is the expected value of sodium content for a given beer brand? So expected value of sodium content for a given beer. That's one thing one has to understand. What is it going to be? Then the next thing is you want to understand is that, like we discussed last time for the buttermilk and calcium, same idea. You can say that sodium content differs significantly between brands. Sodium content differ significantly between brands. That's the question to ask. The third question one can also ask is that in general, in beer, what's the sodium content? So what is the expected value? Of sodium content in beer? Is zero. And the next thing is that what's the variability of sodium across brands? Of sodium content across. Right. So this is the data set is from a paper in 2005. So I'll just write the paper. It's a paper, the 2005 paper. That's the data I'm going to take. I'll give a reference on the course website. It's like Kuttner et al. So first thing I want to do is let's just load the data set. So for that, we will load up R and try to do that. So this is the data set of the beer data set. So we call it as the beer data set. This code will be there in the notes site, and you can work with it. So, so, so first thing, I load up the data set called beer. Let me first do a little thing for me now. I'll set the working directory to source file location. That's done now. So let me load the data set. Yeah. Let me go down below, and then let's just do a head of DF. So now, since I put header equal to false, it only gives the sodium, the brand, the repetition of the experiments for each brand. So let me just go and give names to the data frame. So the data frame might give the name of sodium, okay. And DF if I do, head DF if I do now, at the bottom, I should get sodium brand and brand. That's good. Then I want the sodium to be numerics and then brand as a factor to which I'm trying to understand the differences. So let me just go and call sodium as sodium. We go brand as make it a factor, just to sort of thing. And then now I will need to plot. I just want to plot and see how how the sodium varies across each brands. So let's just look at head DF, for example. That is gives you brand one. Then let's just do head DF, let's say 100, first 100, let's say. So it gives you everybody. So if you go and do this, so the brand one has a certain number of values, the brand two a certain number of values, and so on and so forth. So I just want to just see how the brands waver across. So I just did a box plot. I did not use weirdest colors, but you can fill in brands. So maybe you can just do this. Maybe you can let's just do this. Then I get I'm not introduced LabGE plot. We do that. And then we do this. So this gives you a plot on the side. So of the various brands and how the sodium means. So clearly I just did a box plot. So clearly you can see now that that the sodium brand here has higher mean compared to the sodium brands here, perhaps, and then this little low one on the second brand. So this gives you a first-hand understanding of where the brands are in some sense. Right? So now, let's try and answer the first question that we had, like what is the expected value of the sodium content for given brands, right? So what I'll do is just this first command is just to give a box plot of sodium content versus brands. Okay, now let's go down. Let's try and understand let's do an analysis variance model, analysis variance over for the beer model. Okay. So I attach the data frame. So then I don't have to keep on mentioning DF and all. So to do this, so the first thing I'll do is I'll do an ANOVA, a simple ANOVA, right? So when I do that, you look at this. So now there are 6 brands. Let's get 6 degrees of brands, 6 repetitions, 6 degrees of freedom. Then the sum of squares within brands is this, the mean is this, the F value is this, and the P value is so much. Right? So it gives you an immediate the probability of F tells you that okay, there is difference. And then I just do I just try to do what the means are in each branch. So I do this. So if I do this, I run this command, so I get like um, so immediately get the brand one, the mean is 23.6, like we said here, and brand two so much, and brand six is so much. So immediately get that. So now this sort of the first part tells you immediately that what is the expected value. If you want to understand, let's say what is the expected value of the sodium content. This is what content for given branch. Right. So the ANOVA tells you that you should reject the fact hypothesis that they're all the same. It's clear. Then this mean comment tells you that okay, fine. That is the mean comment expected value each brand is like of this kind: 23.6, 10.7, 19.3, and so on. So then the question actually I asked you was that do the sodium content differ significantly between brands? Right. So here, let me just do this is the same ANOVA between the AOV function. I'll use the AOV function between so I'll do a summary of that. Right? So do a summary of that again. The same thing happens. I get the same expression like that as well. And F touches gives you a p-value, and then of course it's ANOVA. So it's the ANOVA sum of squares. The degree of freedom is 5 because there are 6 branches. One is 10, and the residual error is 42, and so that's one immediately. So then the next thing one can do is one can understand if you want to go and see so you want to go and see the next question which I asked, what is the expected value of sodium content? That's the question I asked next. Content. So what I did here was I just applied the mean function across branch, and I compute the variance as well. Next one. So if I do this, so I computed the mean, and then I looked at the variance of the mean. Let's do this. So mi is this. So we go down one line. We come up one line. We do mi of this, and then I the raw mean I. So that's 21.6. That's the variability of this answers the question. This is one question, and second question is what is the variability? What is the variability of sodium content between those? So we put mi here, so you can see mi as well. The mi is the same as it's a little different from a little bit more detailed. The same thing as the previous ones. Is this the same value? So the apply function applies the mean across each branch, and the variability gives you that. So then you can also give you a constant interval. Once you do this, you can just do a vector. This mean and sodium. Just do that. That's like the mean sodium is 17.6, and the deviation is like 0.7. So this whole thing now is what I'd like to do is like discuss the ANOVA model, and then come back and do this whole thing, go from fixed until I've done fixed effects. So now I'll try and do the next lecture. I'll try and do the random effects. I'll try and do random effects next. Very good.